Okay, so this section 2.5b will be about solving solving radical equations and absolute value equations. So let's get started with um, this example where you're going to solve this equation. If you have multiple solutions, then you will separate them in using a comma sign. And if there's no solution in MyOpenMath, you're gonna need to type D and E, meaning do not exist. But in this case, we're gonna go ahead, show you step by step how to solve, mostly when you have a radical equation where the radical index is even. So let's write the problem down here. So we have x, the problem is x equals the square root of 132. X equals the square root of 132 minus x. So to cancel the radical, we would raise both sides to the power of the index of the radical. So the index of the radical here is 2. When you don't see anything, that means it's 2. So I raise both sides to the second power. So that is x squared over here equals the square cancels the radical. So I'm left with 132 minus x. So this is a quadratic equation because you have multiple exponent for the variable, and the highest is 2, makes it a quadratic equation. So we're gonna put it in standard form, moving everything on one side. X squared plus x minus 132 equals 0. So then we have multiple ways to solve a quadratic equation. So far, this one can be solved by factoring. So if I find two factors of negative 132 that the sum is 1, negative 132 that the sum is positive 1, then I can just factor this expression easily and directly. So what are the two factors? Negative 132, the two factors of it are negative 11 and positive 12. So the factored form is x minus 11 times x plus 12. So if I use the zero product property, x minus 11 equals 0, or x plus 12 equals 0. So x equals 11 or x equals 12, negative 12. Now, the danger when you're solving those type of equations is that the solution you get is not always your solution. You may want to verify or check for extraneous solution. So we need to check for extraneous solution. Extraneous so we're gonna start with x equals 11 and then x equals negative 12. So when x equals 11, we're gonna have 11 equals the square root of 132 minus 11. So that is 11 equals the square root of that's 11 minus the square root of 129. Is it 121? So that's 121. So 11 equals 11. This one is checked. So we can say that x equals 11 is accepted. X equals 11 is an accepted solution because we verify the equation for it. Now we're gonna try for x equals -12. For x equals -12, you're gonna have -12 equals the square root of 132 minus -12. So that's -12. So -12 equals the square root of, that's 132 plus 12, that's 144. And -12 equals square root of 144 is 12. -12 is not positive 12, so x equals -12 is rejected. Would be rejected because this value did not verify the solution. So your solution is the single set of 11. So here, I always provide the answers here. So that's 11. So this next example will be about the same thing. But the one thing that we want here is that we want to make sure that the radical part is isolated. So we're going to add 1 on both sides. So we would have the square root of x plus 5 equals 1 minus x. And then we will proceed the same way. Make sure that we remove the radical by raising both sides to the power that is equal to the index. The index here is 2, so let's raise both sides to the second power. So the radical gets canceled on this side, x plus 5 equals, well, we have to be careful here. If we have a plus b squared, that's not a squared plus b squared. No, it's not a squared plus b squared. So we need to FOIL to solve a plus b squared. That's a squared plus 2ab plus b squared. We don't want to forget that. So that's 1 squared minus 2 times 1 times x. So that's 2 minus 2x. Minus 2x. And then plus x squared. So that's 1 plus minus 2x plus x squared. Now we're going to make sure that this equation is written in a standard form. So that's x squared minus 3x minus 4 equals 0. So basically what I did is I subtracted x on both sides and subtracted 5 on both sides. Here, subtract x on both sides, subtract 5 on both sides. Then that gives me this equation right here. That is x squared minus 3x minus 4 equals 0. Two factors of -4 that add up to -3 are 1 and -4. So we can factor this as x plus 1 because coefficient here is 1. X squared coefficient is 1. So we can break it down as two factors, x plus 1 and x minus 4 equals 0. X plus 1 equals 0, or x minus 4 equals 0. So the solutions will be x equals -1 or x equals -4. But obviously we know that we need to check for extraneous solution. Extraneous solution. So we would check for x equals -1, and we will check for x equals 4. Now for x equals -1, we would have square root of -1 plus 5 minus 1, square root of -1 plus 5 minus 1. Is it equal to negative? So that's square root of 4 minus 1. Is it 1? So we have square root of 4, that's 2, minus 1 equals 1. So 1 equals 1. This one checks. So x equals -1 is accepted. So this is accepted. I like to put it in green when it's accepted. And then that's the solution we accepted here. Then we're going to check for x equals 4. That's the square root of 4 plus 5 minus 1. We want to know whether it is -4, right? So that is square root of 9 minus 1. Is it -4? So that's 3 minus 1. Is that -4? Not quite 4. That's 2. That's not -4. So that is not -4. So that means x equals 4 is rejected. And I like to have the rejection in red, and then just color would make the difference. And your solution here will be just -1. The solution is negative. Okay. That is the second example. Now let's move on to the next example here. That is the next example here. That is this one. So we're going to subtract 5 on both sides. And then we get the square root of square root of 8x minus 55 equals x minus 5. And then to remove the radical, we would square both sides because the index is 2. So we have 8x minus 55 equals x squared minus 10x plus 25. Obviously, you see that we do x minus 5 squared equals x minus 5 times x minus 5, and we FOIL. So now we're going to put it in standard form so we can solve the quadratic equation. So we can subtract 8x on both sides and add 55. Subtract 8x and add 55. So that is x squared minus 18x plus 75 plus 80 plus 80 equals 0. Two factors of 80 that add up to negative 18 are negative 10 and negative 8. So the factored form would be x minus 10 times x minus 8 equals 0. So the zero product property, x minus 10 equals 0, or x minus 8 equals 0. Two solutions, x equals 10 or x equals 8. So we're gonna check for extraneous. We're gonna check for extraneous solution. X equals 10, x equals 8. We got square root of 8 times 10 plus 55 minus 55 plus 5 equals 10. This one would be square root of 8 times 8 minus 55 plus 5 equals 8. See? Yes. So that will be square root of 80 minus 55 is 25 plus 5 equals 10. 5 plus 5 equals 10. So 10 equals 10. X equals 10 is accepted. Here that is 64 minus 55. 64 minus 55 is 9. So that is the square root of 9 plus 5 equals 8. 3 plus 5 equals 8. So 8 equals 8. This one checks. So x equals 8 is also accepted. So we have the two solutions, and your solution set is 10 and 8. I like to put them up here, 10, 8. Okay. Our next problem this time is absolute value. So when solving an absolute value equation, here are a few things that we need to remember. We should remember that the absolute value of an expression, of a number, can be either the actual number or the opposite of that number. Well, again, the absolute value of a number can be either the actual number if the number is positive. So absolute value of 2, absolute value of 2 is the same number, 2, because 2 is positive. Absolute value of negative 2 is 2 because absolute value cannot be negative, 2 being the opposite of negative 2. So the absolute value of a number can be the number if this number in absolute value is itself positive. An absolute value of the number, if it's negative, then will be positive, which is the opposite of that number. So you have to understand this first, because when you see absolute value, you need to make sure that you understand that this is not just one solution, a possibility. It's a study of cases whenever you are solving an absolute value equation. So here are the steps. Step 1, you have to make sure that you isolate the absolute value. So in an equation like this, I want to make sure that this portion of the problem is isolated, which means that I'm going to move this over by adding the 2. So that's the first thing. When solving an absolute value equation, we need to isolate the absolute value. We isolate the absolute value. Number 2, so we're going to create 2 cases based off the study of the absolute value, because we are studying the possibilities. If the expression in absolute value positive, we know it's the same number. But if it's negative, then we need to consider the opposite. But the easiest way to put it is that, okay, if I have absolute value of A, of X equals A, 2 considerations are possible. That's the absolute value equals A, or that's X equals A, or the expression inside of the absolute equals the opposite of that number, because the absolute value was this number. So if I know that this number is positive, if the number is positive, then it's itself. And then if the number is negative, then it's going to be the opposite of that number, because the number cannot, the absolute value cannot be negative. So that's the second situation, second consideration. And then once you have your step 2, which is breaking the cases down, create 2 cases. The third step is to solve each case, the first one and the second. And we also here in this case need to check for extraneous solution. We check for extraneous solution. Once we do that, then we present the solution set. Okay. And now we can start with this example that we have, which is absolute value of 5z plus 6, 5z plus 6, an absolute value minus 2 equals 7. We isolate the absolute value step 1. By adding 2 on both sides, we have absolute value of 5z plus 6 equals 9. Next, we're going to create the 2 cases. That's the expression in absolute value 5z plus 6 equals the number, or the same expression 5z plus 6 equals the opposite of that number 9. Now we're gonna go to the next step, which is 3 solving each case. So 5z plus 6 equals 9. 5z plus 6 equals -9. We subtract 6. 5z equals 3. Divide by 5. Z equals 3/5. Or subtract 6. 5z equals -15. Divide by 5. Z equals -3. Now we want to check for extraneous solution. You're going to check for extraneous solution. So we have absolute value of 5 times 3/5, because z equals 3/5, plus 6 minus 2. Is it 7? We don't know yet. 5 cancels, so that's absolute value of 3 plus 6, absolute value of 9, minus 2. Is it 7? 9 minus 2. Is it 7? Yes, 7 equals 7. So z equals 3/5 is accepted. So we have the first one. And then we can check for the second one. We have absolute value of 5 times z equals -3 plus 6 minus 2. Is it 7? So absolute value of -15 plus 6 minus 2. Is it 7? So absolute value of -9 minus 2. Is it 7? Absolute value of -9 is 9. So 9 minus 2. Is it 7? Answer is yes. 7 on this side is 7 on the other side. This is checked. So z equals -3 is also accepted. So we have both solutions accepted. We have both solutions accepted. So we can say that your solution set, the solution set is 2/3, 2/5, 3/5, 3/5, and -3. So up here, solution set is 3/5 and -3. So that's a solution for the first example of absolute value equation. And we will not forget the steps we need to use when we're solving absolute value equation. So next example here, we will do the same thing, but the one of the mistake you don't want to do, you don't want to combine these two, because They don't belong together. The -2 multiplies the absolute value. The 1 is added. So we need to isolate subtract the 1 on both sides. So we get -2 absolute value of -9x plus 5. And we're not allowed to distribute that 2 either, because we need to make sure that we isolate the absolute value just like we would isolate the x if we had an x over there. So we need to make sure that this part is isolated correctly, just like you would call this one a z by itself, and then you would take the steps to get it by itself. So that equals 8. That equals 8 because 9 minus 1 is 8. Then we divide by -2. So we get absolute value of -9x plus 5 equals -4. Well, the one thing that we already know here is that this equation will have no solution. We already know that because absolute value of a number cannot be negative. But how you demonstrate this? You need to demonstrate the steps of your answer. We're gonna do that, right? But we already know the answer would be no solution. Since we're not looking for answers only, we are looking to demonstrate steps and understanding. That's why we need to show the steps. So we know the steps. Step 1 is to isolate. It's already isolated now. Next step is now to create the 2 cases. The 2 cases will be, one is the -9x plus 5 equals -4, and -9x plus 5 equals +4, the opposite. So we're going to solve both of them. -9x plus 5 equals -4, or here's an or here, -9x plus 5 equals 4. We subtract 5 on both sides, so we can get x by itself. -9x equals -9. Then we divide by -9. We get x equals 1. And then here we can subtract 5 also. We get -9x equals -1. And dividing by -9, we get x equals 1 over 9. We're going to check for both of them in case one of them is extraneous. One of them or both of them can be extraneous. So we have absolute value of, well, actually 1 minus 2 absolute value of -9 times 1 plus 5 equals 9. Well, is it 9? And then over here, we're going to use this, but that is 1/9, 1 over 9. So this one will be 1 minus 2 absolute value of -9 plus 5. Is it 9? 1 minus absolute value of -4. Is it 9? 1 minus 4. There's a 2 right here, right? There's a 2. Uh, 2 times 4, is it 9? So that's 1 minus 8. Is it 9? So that's not 9 because negative 7 is not 9. So this one does not verify. Over here, 1 minus 2. 1 minus 2. Negative 9 times 1/9, that's negative 1. So absolute value of negative 1 plus 5, is it 9? One minus absolute value of 4. Oh, there's a 2, absolute value of 4. 1 minus 2, absolute value of 4. Is it 9? 1 minus 2 times 4, is it 9? So 1 minus 8, is it 9? Negative 7 is not 9. So none of the solutions work that coincide with what we predicted for this equation. None of them works. So then we have no solution. In the case of your on no solution, which is the same as the empty set, but in the case of my open math, you're going to put D and E as if the solution does not exist. So next example. So the same process, we'll isolate the absolute value and then create the two cases, solve them each, and then check. So that's 5. Well, basically what we do here, we will add 14 on both sides first. So we have 5 absolute value of negative 9 minus 9/7 W equals 20. Divide both sides by 5 to get absolute value by itself, the absolute value part by itself. So absolute value of negative 9 minus 9/7 W equals 4. I'm going to create the two cases. The two cases that I need are, I will create are negative 9 minus 9/7 W equals 4, or negative 9 minus 9/7 W equals negative 4. So separately, we're gonna solve them. We can add 9 on both sides for each. So we would get negative 9/7 W equals 13, or negative 9/7 equals 5. W equals 5. Negative 9 9/7 W equals 5. Now to get W by itself, we can multiply both sides by negative 7/9. So we multiply both sides by -7/9. We do the same thing here too. -7/9. And we multiply this by -7/9. So -7/9, that cancels. Negative turns positive. So W by itself over here, that's -13 times -7. That's -91/9. Or W here equals -35/9. We have the two values. We're going to check to make sure that we get everything correct and work. So check here and check this one as well. So we're going to go back to absolute value. Okay, 5. Absolute value of -9 times -9 minus 9/7 times the value of W, which is -91/9 here. Plus 4, is it 14? Plus 14, is it 6? And then we're gonna check for the other one as well. Just gonna copy this and replace the top here by 35. Okay, and then we're going to perform these operations. 9 cancels, right? And then we got 5, absolute value of -9, and the minus, these two minus will be give me a positive 91 plus 14. We check to see if this is 6. Okay, and then we will continue this. Plus or minus? It was -14 actually. It's -14. It's -14. Okay, so that's 5. So yeah, but we have negatives, we have 7 here. And so that is -9, 91 divided by 7. 91 divided by 7 is 13. It's a plus 13 minus 14. We want to check to see if it's 6. So that's 5. Absolute value of 4 minus 14, is it 6? So that's a 20 minus 14. Is it 6? Yes, is 6 equals 6. This one checks. So x equals -91/9 is accepted. Now we're gonna work with the second option to see if it works. That's 5. Absolute value of -9 minus 9/7. Well, actually, we can simplify this, right? That's 9 cancels out. Negative, it's a plus. Negative, negative, those two negatives. And then 35 divided by 7. 35 divided by 7 is 5. So 5 minus 14, we want to see whether this is still 6. 5 absolute value of -4 minus 14, is it 6? So 5 times 4 minus 14, right? Is it 6? That's 20 minus 14 that we want to know if it's 6, and we do know that's 20 minus 14 is 6. This one also checks. So that's x equals -35 nines is also accepted. So both accepted. Then we have the solutions for the absolute value equation that are -91 over 9 and -35 over 9. So I like to write them up here because they ask for the answer. So that's -91 over 9, -35 over 9 are the two solutions of this equation. So that's it for module 2.5b.